All right, I guess we'll get started. My name is Alex Turner. I'm the program manager for the C# compiler at Microsoft. And this is a talk really about the new features in C# and Visual Basic that sort of come together to provide a really good interop experience, a really improved interop experience with a lot of kinds of object models that have really had a poor environment in the past when you wanted to talk to them and you wanted to interact with them. And specifically, we're going to be looking at Silverlight, Office, and Python today. And hopefully, many of you guys got to go and check out Anders' session yesterday, The Future of C#, where he was able to sort of go over all the new C# features that are coming out for the new release, C# 4.0. And hopefully, if you're interested in VB, you'll be able to catch Paul Vick's session today at 5:15, where he's going to go over the new VB features that are coming out in VB 10. But really, this talk is about sort of the subset of the features that are in C# and VB that are really about interoperating with object models that are maybe a little more foreign than typical object models, like the kind you'd find in the .NET BCL. And the best way I have to sort of present this idea of natural interop, is to sort of look at a history of C# and VB. Sort of looking back, C# and Visual Basic came about, Visual Basic.NET at least, came about at the same time as the .NET platform was coming about. And it was really about having an awesome way to manipulate, consume, and produce strongly typed libraries. And this is really what these two languages have sort of come to excel at and have grown into. And as we've evolved the languages on VS 2005, where we added generics, and VS 2008, where we started to add link, it was really about increasing that expressivity you have when talking to these statically typed libraries. But these aren't really the only libraries that people end up having to talk to. There's plenty of other object models out there that don't actually fit into this rigid bucket. If you're doing something like Silverlight, where you want to talk to the HTML DOM, you want to talk to the browser, the page that you're on, and have it manipulate things, set the title of the page, manipulate JavaScript objects that are on the page. That's a very dynamic thing that you're doing there. And it doesn't really fit as well with the paradigm that you have of a statically typed environment and things that are known in advance, objects that you have that are known in advance. When you're talking to COM, there's plenty of things that exist in COM that C# specifically has chosen not to implement. Things like named and optional parameters, and a few other things like index properties can make it a bit annoying to actually consume COM as easily as you used to consume it back in the day when you would code in VBA, or even today when you code in VB.NET, which did retain a lot of that functionality. And we're also starting to target new things. So we're starting to say, expand the platform to new environments like Iron Ruby and Iron Python. And we don't want these to be islands. We want you to be able to consume these from any language. If you're in C#, to be able to call, just like you can call to a library someone in VB made, you also want to be able to call to a library somebody made in Python or Ruby or such. And so you want that good experience, and you want to sort of feel like you're in your language and you're having a rich interoperability with this other language, this other library written for a different language. And you don't want to have to jump through a bunch of hoops to get this accomplished. And we'll see sort of an overview here of some of the hoops you have to jump through today to do these things. When you're looking at the HTML DOM, for example, let's say we're writing a Silverlight app and we're writing it in C# 3.0. We're using VS 2008. You might have some chunk of code here where you want to do something. You want to manipulate some object that's not in the Silverlight app itself, but it's outside the Silverlight app on the browser page. And in this case, well, you could do it one of two ways. You could call out to a JavaScript function that's defined on the HTML page itself, in which case the code might look like this. It's a pretty simple, concise code. You're newing up a new VE lat long. That's some object, some JavaScript object that exists. You're calling a method on, or a function on map. You're saying add pushpin. You're passing in that new loc object that you made. And then you're going on to call more functions. You're calling pin.setTitle, pin.setDescription, map.setCenter, and zoom. You're calling these things in sequence. And this looks pretty much like what you might expect from something like C# if you had like a fully static environment, a fully static object model to deal with. But the code you have to write, if you actually are in C# 3.0 and you want to interface out directly without calling a JavaScript function, if you actually want to just interface to these objects that are in the browser page, you have to jump through a lot of hoops, and it really starts to not feel like C# anymore. To make that new VE lat long object, you have to call create instance on some sort of HTML window object. You're passing the name of the type you want to create as a string. And then as you progress forward, every function you're invoking has to then be also passed as a string to an invoke method. You don't feel like you're actually invoking a function yourself. You feel like you're sort of calling out to someone else to do it for you. And you don't have that fluent experience you have when you're in a statically typed world. Or even here, when you're in JScript, where the syntax is designed. The object model and the syntax mesh together. You have similar situations in COM, specifically with C#, not with VB.NET. If you look back to VBA, which is really the language COM object models, such as the Word and Excel object models, were designed around, you have code perhaps like this. You have a selection object, and you're going to say .paste special. And you're passing one parameter, the link parameter, and you're giving it the value true. And this is a really nice, concise way to say, I want to paste special and do one interesting thing there. I'm going to say this is going to be a link paste, so it's linked to the source. And in VB.NET, you basically still have the same functionality. A few things changed. You now have parentheses, and you have to qualify it by saying Word dot, because you're not actually in Word. You're talking to Word. But the essence of what you're writing is the same. It feels just about the same thing, and that you're able to just express the core of what you want to say without too much fluff. But if you want to talk to this kind of stuff from C# 3.0, it's a big pain. And if any of you have actually done Office development with C#, this should be very familiar to you. This is probably about the worst case situation you can have. This is something from the Word object model. So not only do you have missing parameters that you have to specify because there's no support for optional parameters, but you then have to put them into temporary variables to pass them in because the Word object model sort of goes overboard and uses by ref parameters all over the place, even when the parameters are not really by reference. This was something that didn't really matter back in VBA, but it does matter in C#, where you have to explicitly say ref and pass an actual variable when you're calling something. And you want to pass the value by reference. And finally, the third example we're going to talk about is Python. If you're in Python and you're consuming a Python library, well, that's probably the best situation you can be in. And you have something you can do in just sort of 2 lines. I can say, if I want to import the shuffle method from the random module, I just say import random. I now have random as a name that I can use. And I can say random.shuffle items, assuming I have some sort of array of items that I wanted to shuffle and reorder. But today, we do have the capability to have Python and other languages interoperate, and that kind of hosting is a great goal of Python. But for this kind of one-off thing where you're really operating at the scope of a using, where you really want not to sort of execute a huge block of user code or to sort of set up an entire environment, where you just really want to say, I want to do the equivalent of in C# a using, or in VB an imports. And I just want to bring in some functionality that's already existing for me in Python and use it fluently like I would something that was written for .NET, for static world. I really can't easily do it. I mean, here's some code that did actually work at some point in the past, but it's a real headache. You're actually passing Python code in a string to the Python environment to actually get this to evaluate. And this really doesn't feel like C# at all. And you could consider that this isn't really a feature. Someone may have just actually found a way to make this work. But this really doesn't give us that experience we want, the experience of being able to easily import a Python module and sort of operate on it as if it was a module in C# or VB. And so we're going to look into these cases today. And I'm going to do this in a way that you guys can actually go home and try out yourself, because the samples that I'm actually using are available publicly. If you have the CTP, you can actually download our C# Future package and the sample package. I'll show you where to get that at the end. And you can actually try out all the stuff that I'm showing you here yourself. VB is actually going to have, as you'll see, all the same features that I'm showing you. But the VB dynamic support is not quite ready yet, and it isn't actually available for you publicly. So if you do want to try this out, then you, for now, would be trying it out in C#. And so I'm going to go first into Silverlight. And we'll switch over here to the demo computer. And what I have here is the Silverlight starter project that you get in that samples package. And just to show you what it is, I haven't touched it at all. I'm just going to run it. You get a very simple Silverlight interface. And what it has is a text box, which is hard-coded to cat. And you push the get all button, which simulates a web request to a web service. In this case, we're simulating a call to Flickr. And you're getting back a list of images, a list of cat images that exist that match this tag on Flickr. But currently, when you actually click on them, nothing happens. We don't have it wired up yet. And so we could wire this up to just sort of show the image. But Flickr actually is nicer. It actually gives us more meaningful information, a latitude and a longitude. And so we can actually make something cooler. We can make a mashup between the Flickr images that we get and virtual Earth to actually plot where these photos were taken. And so let's actually see how we'd go about doing that. And what I'm going to do is I'm going to first go about doing this the way that you would do it in C# 3.0, the way that you could do this today. And then I'm going to go through and I'm going to transform the code to show you how much simpler it actually gets and how much more understandable it is when you use the new dynamic capabilities that we have now and we're going to have in C# 4.0 and VB10. So the first thing I'm going to do is go to the start page, the web page hosting the Silverlight app we have, and just make two sort of surgical additions to support this. I'm going to go here, and I'm going to insert a script block. I'm going to use snippets throughout the demo to actually put this code in, so you don't have to watch me type some of the longer things. And I'm just inserting the script block to import the virtual Earth control from the web. And this is just going to let me now use this. It's going to bring this into my JScript namespace so I can actually talk about the virtual Earth object model. And the one last thing I'm going to do is come down here to the bottom of the page, and I'm going to make myself, down here, just 1 second. I'm going to make myself a div that's going to hold this VE map object. I'm going to call this div myMap. And this is where the virtual Earth map is going to go. This div is going to be absolutely positioned, and it'll float over my Silverlight control. Because currently, virtual Earth, you can access it through JScript. And so we really need to sort of talk from the Silverlight app back down to the browser to actually get this to appear. OK, so we've made these changes to the start page. I'll go back here to page.xaml.cs. And you see there's basically 3 methods that exist now that do the functionality that you already saw. If I go to void init, you see, well, it's not doing anything yet. Button search click is what happens when you actually click the search button. It's loading the sorts of items that we actually have. It's fetching for the cat images, the list. And when you actually click an item in the list, it's just picking out that selected item, but it's not doing anything with it yet, which is why nothing happens. So the 2 things we really have to do to actually make this come alive is first to set up the map. And so we're going to call a getMap function that we'll define when the page is initted. And also, when somebody clicks on the selection in that list, we want that to add a push pin to the map and navigate to it. And so we'll make a function that we'll define for that too. OK. And so now all we have to do is define this getMap function and this addPin function, and we'll be set. So let's see how we do this in C# 3.0. So I'm going to go here. I'm going to type out a snippet here. And this is putting in access for me to the HTML document and HTML window objects for this page, this Silverlight page. And these are basically the bridge for me from my Silverlight app out to the outside world, out to the browser page that's actually hosting the app. And if I actually want to go ahead and use this to accomplish something, I can go here and start to pull in more code. What I actually want first is I'm going to want an object to actually hold on to my JScript map. So this script object is going to be the map control that I'm going to instantiate from Silverlight, but instantiate in the browser. And script object is just a Silverlight object that's provided to you that is your interface to a specific JScript object that exists out in your browser page. And for now, it's going to be null. But then when the map is initialized, when getMap is called, we're going to call out to this HTML window. We're going to call createInstance. And I'm going to pass it that VE map. But you notice I'm passing it as a string. And this is because, as far as the HTML page.window knows, this is just a generic browser page. It doesn't know anything specifically about what's on it or the fact that I brought in this specific JScript object, the virtual Earth object. And so I have to give the class name as a string. And then you notice I'm giving the parameter name myMap, the div I want to actually put this map in, as another string. And OK, so I do that. It's going to create this instance, and it's going to give me back a pointer to this map object as a script object. OK, now I want to do something. I want to actually load the map. So I'm going to call map.invoke to load the map. But you'll notice that I'm calling map.invoke. I'm not actually just calling map.loadMap. I have to call something intermediate, this invoke method. And I don't really feel like now I'm actually using C#. I feel like I'm sort of using this translation layer. Everything I do has to sort of go through this extra level of indirection to actually occur. And if we go down to add pin, where the pin actually gets added to the map, we'll notice that, well, we have another create instance. We're making a position here of VE lat long. This is just a location on the world. This is where the we're going to actually send it the latitude and longitude, and this is going to be where the pin goes. But again, I have to call create instance. I have to send the name of the thing as a string. I'm going on. I'm doing a bunch more invokes down here to set the title and description. And actually here, I'm calling an invoke add push pin that's going to return me another object. But because this thing that's returned to me could be a primitive, it could be another object I might want to manipulate further, invoke, as defined, returns me object. And it doesn't return me script object. And so I have to go out of my way to now do a cast. And so I'm inserting a static cast, which seems like it would help me guarantee or ensure type safety, except that the cast is meaningless. It's casting to script object, which just represents some untyped scripting object. And so I'm not really gaining anything here except a lot of annoyance of all these hoops I have to actually jump through to get anything accomplished. But lo and behold, if you actually do jump through these hoops, and I run the program, oops, let's see what happened here. Oop, have to actually pass selected down here. So if I run this, we can see that the map does appear. I can scroll around it. It's a real map. I hit get all. I can now click on the cats, and I notice that when I click on it, and now I hover over the push pin, I get an image of this cat. I can pick a different cat. This one's in Ohio. Load that. It's actually 2 cats. Go down here, find other cats. And basically, as I click on these, I'm actually bringing in the pin. I'm actually loading the pin in the map, and then I can hover over it and get the data. And so my app is functioning. And I could do this before. But the app was really kind of annoying to write. And if I had to sort of keep doing that, it's not really an incentive for me to want to actually code against the JScript object model. I might just say, well, I'm just going to make a JScript function and call out to it, because I have a much more fluid experience there. And so let's see how this can get a lot better when we actually bring that dynamic capability into the language and regain the terse syntax we have in JScript. So I'm going to go back here, and I'm going to go up to my HTML document object, doc that I'm setting up here. And as you saw in Anders' talk, I now have a dynamic class, a dynamic type that I can use to say that, well, I don't actually care about the static type of this object. What I care about is the fact that I want to dynamically dispatch the operations I'm going to perform on this object and have the runtime figure out what to do based on the type of this object. And so I'm going to replace here HTML document with dynamic. And I'm actually going to make one more change. And this is a change that's only required because of our sort of preview status here, the fact that this is a very early preview. But I'm calling an extension method off of document called asDynamic. And there's an important difference here, and there's an important reason why I had to do this. When I first said dynamic doc equals, if I just left that to be HTML page.document, I would be gaining dynamic access. My calls later on would resolve at runtime, but they would be resolving to the static shape of HTML document, the fact that HTML document has a create instance method and invoke method. And so I would be accomplishing the same thing, but it would just be resolving at runtime, and I wouldn't be gaining any benefit. I would just be adding another layer of indirection, and I'd have the same code. So what I really want to do is I want to have sort of a logical wrapper around my HTML document. I want to say, well, instead of accessing the static things I could have accessed anyway, I want to say, well, just call this method loadMap. Instead of looking for a real method loadMap, I want the object to do its own internal logic to say, hey, I know I'm a bridge to this browser page. I'm going to go look for some loadMap method on the browser page. And so it's representing an abstract operation that the object can choose how it wants to interpret. And this isn't going to be necessary forever. The actual magic that's going on with asDynamic is the fact that its return value implements the special DOR, dynamic language runtime class, iDynamicObject. And all iDynamicObject means is that a given object knows how to dispatch operations on itself when acted upon dynamically. And if an object isn't iDynamicObject, you'll get the default static behavior at runtime. But when an object implements that interface, it can then decide for itself exactly how it's going to dispatch its operations. And so I'm going to do the same now for HTML window. And I'm actually going to do the same for the map object, because once I get back this map object, I don't want to deal with it as a script object like calling invoke. I want to deal with it as a JScript object. I want to be able to directly do things to it and have the runtime figure out what that means. So I'm going to call this dynamic as well. And so I'm going to go down to my getMap method, and I'm going to start rewriting all this to use the more terse syntax. And I'm going to start actually with the invoke call, because it's the simplest to understand. And so before, I had to say map.invoke and pass loadMap. But what I can actually do now is just directly say map.loadMap. And I'm directly calling some function. The compiler can't figure out whether this actually works at compile time because the type of map is dynamic. And so it doesn't know anything about the object it's actually going to hold. But the compiler will now know that it's going to generate this call, that's sort of similar to VB late binding, where it's going to figure out what that means at runtime. And because map is going to actually turn out to be this idynamic object, it'll ask the object to go ahead and figure out what it means for me to call load map. So the object can go off to the browser page and make that intelligent operation, rather than just duplicating what I could have done statically. And so I'm going to go back up here to create instance. And this is actually an area where we're still sort of planning this out, and it's under discussion within the team. But you'll notice that what I can do is call here win.new as a token .vemap. And then just accept this single constructor parameter as an actual parameter. And this is just an arbitrary syntax. There's nothing special about this, the fact that it's .new and then .vemap, except that that idynamic object I had chose to accept this as a mechanism by which it will create objects for me. And so because I need this mechanism to make my vemap object in JScript, and we don't yet have a dynamic new operator in C#, the object model, the IDO, is able to actually implement this and say, if it sees this pattern, it's going to make me a new vemap object. OK, so now I have this. I have this for getMap. And I can go through and do the same translation for add pin. I'm going to want this script object to be dynamic. I'm going to call, instead of create instance, I'm going to call new.velatlong. And I'm going to pass the parameters here in parens. And you'll notice that my syntax is getting short enough that this actually now condensed down to one line. And I'm going to keep going. I'll call this dynamic pin equals. And I can just do here map.invoke, but I'll turn the invoke into just map.addPushPin. Oops. And you notice I no longer need my cast, because I know I'm dealing with a dynamic environment, which is JScript. And so it wasn't particularly meaningful to me to distinguish between what the object was I was getting back, because I know it's just some runtime object that I want to figure out in the JScript engine. And so by using dynamic throughout my program, I'm now avoiding these casts that didn't actually give me any meaningful information to begin with. And so, OK, dynamic pin equals that. I'm now going to say, OK, pin.invoke, but I'm going to change this. And I'm going to do this same transformation for each of these. Basically, pull this down. And put parentheses here. And we'll see if I run my program now. I've cleaned up my code, but I still have the same functionality. The map is still appearing. When I run, I can still get pictures of cats. I can scroll down and click a cat. This cat's from Italy. And so I'm actually able to keep doing the same things I was able to do before. But if you actually look at the code that I wrote, this code feels much more like the code I would actually want to write. And this feels much more like the code I might expect if this wasn't dynamic. If this was some sort of statically typed C# library or VB library that I was consuming, I would expect to be able to just have my objects call my methods and pass it the parameters, and not deal with all this friction of having to say .invoke and other things like that. And so I've really been able to clean up the code and really feel a lot better about actually doing this in C# now versus having to drop down to JScript. And in fact, I'm actually gaining one benefit, one actual concrete benefit, besides just cleanliness over that. And it's the fact that this add pin method is able to take not a bunch of strings, something that JScript will understand, but the entire item. Because I've remained within C#, I'm able to still process my objects as .NET objects. And then here for item, I'm able to split it out, the latitude, the longitude, the title, and description as I need. I don't have to break apart my objects just to sort of marshal them over to JScript. And so I'm able to stay in my data domain and really remain with this rich experience and a lot of the benefit of using Silverlight in the first place. So go back to the slides and just take a look at what we've actually done. If you remember the JScript that we were considering writing, well, the C# 4.0 code that we wrote, except for the first line where we're still trying to figure out maybe exactly what we want to say and how you want to new things up, the last 4 lines turn out to be actually identical. And that's a coincidence. You're not going to be able to just copy and paste all of your JavaScript code into C#, but it represents that we're operating at the same level of complexity. We don't have a whole lot of annoying baggage that's fluffing up the code and making it so I really can't easily read it and figure out what's going on anymore. And in VB10, when you notice that we're basically getting to almost exactly the same place. Instead of having a dynamic type, though, VB is treating this the way it always has actually treated sort of this late binding idea, where if something is typed as object, you're able to then do this type of late binding off of it and have the stuff resolve at runtime, except that we're now extending VB's late binding so it can participate with this whole idynamic object system. And the one catch here for VB is you'd have to turn option strict off. But VB actually allows you to customize the extent to which you turn that off. So you could leave it on for things like implicit conversions, but turn it off for late binding if you started to use dynamic and you wanted to rely on it. And so the next thing I'm going to show is the improvements that we've actually made to Interop, another domain where you want to talk to a library that's really designed for a different language. In the HTML DOM case, we were talking to an object model that was designed expecting JScript, and the fact that JScript has this dynamic dispatch. And now we're going to be talking to COM, and COM is expecting VBA. When Word and Excel as object models were created, they were created expecting the language that would naturally consume them, which was at the time VBA. And that led to a natural, nice progression, which is why VB.NET will actually already have all the features I'm going to show you. But we'll see how C# is actually catching up to where VB has been. Oops. Let's switch over. OK, so I'm going to go down to Office here, and we're going to just put together a simple Office app. It's actually a simplified version of the Office walkthrough, if you actually follow through the walkthrough documents in the VPC. And we're going to basically just take a list of accounts, put them into a spreadsheet, and then copy and paste that spreadsheet into Word to start making a report. And so to get started, we just need a simple account class. So I'm going to use a snippet, put in an account class for us to work with, ID and balance. That's all we need. And use some object initializers to actually make us a set of these accounts. OK, and so now let's actually fill up our spreadsheet so we can go and actually get this going and see the kind of pain points you actually hit today in C# when you're trying to do Interop. So all right. I'm going to start filling my Excel application or my Excel workbook. First, I set up a new Excel application. This is fine. But then I want to add a new workbook to the application, a blank workbook to work with. But I'm already starting to hit some of this annoyance that I didn't have to deal with in VB.NET if I was using that. And it's the fact that this add method I'm calling takes a parameter. But this is a parameter that you don't actually usually want to provide. Most of the time, you're just going to want to send nothing and just get a default workbook back. You're not going to want to specify a template. And before, the way you had to handle this in C# 3.0 was to pass type.missing, which is a value, a special value that represents the value of an optional parameter when it's not specified. And so now that I actually want to call this, I have to specify this type.missing, even though I just really want to just say I'm calling the add method. And so if you notice, though, when I hit the parenthesis now in C#, this being C# 4.0, I notice that there's brackets around object template. And this is the syntax that tells me, OK, this is an optional parameter. And so now, moving forward, I don't actually have to specify this parameter. And I can sort of get that same benefit I got in VBA and that I get today in VB.NET, and I can just leave it out. And so because I don't want to specify a template, I can just call excel.workbooks.add with no parameters. Similar to what I'd do if there were overloads, but COM as an environment doesn't have overloads. It uses optional parameters instead. And so, OK, so that was one improvement that I made. I was able to use optional parameters and shorten that. This excel.visible equals true line. There's not much to go on there. But I have this one thing here. OK, excel.range. I'm casting the result of excel.cells to excel.range. And then I'm calling this value2 property on it. And so, again, if any of you have actually done Interop before, you might recognize some of these hacks that people were doing here. But this is actually sort of two things in one. If I look at excel.cells, this is actually returning the arrange object. So far, so good. I have a static type. I could do things off of it. I could hit dot and get the actual methods. But this indexer that I'm calling to actually get the first row and the first cell of that range returns object. And this is something that happens often in COM APIs. It's statically typed up to a point, but then it starts returning object to you. The type system sort of peters out. And so in this case, I've had to now cast this to excel.range to actually get access to any of the things that are on it. But once I do so, I can then hit dot, and I can access all of the properties that it has and the methods that it has. But what I really want to call in this excel.range I have now is the value property. But unfortunately, the value property uses a feature, another feature that's not present in C#, which is indexed properties. Indexed properties were a feature that came about in VBA where a property, like a method, could actually have parameters. It's a similar concept to indexers. And by actually specifying these parameters, you would then get back a value. But if these parameters were optional, you could actually leave off all the parentheses and just treat it like a regular property. And so when I actually look here, if I want to call the value property that I know exists, it's not actually there. C# doesn't show it to me. And that's because C# can't actually parse indexed properties as real properties. I have to actually go down to that underlying get underscore method and call that to access the indexed property. And if I actually hit parenthesis to look at the parameter help, I notice, well, all it has is one optional parameter that I could care less about. I don't actually want to specify that parameter. Actually, in this case, it's actually a set, not a get I'm doing. But the real parameter I care about here is that second parameter, the value parameter. The first parameter here is just some fluff I don't really want to specify. But if I wanted to call set value, I could say type.missing, hit a comma, and actually specify this ID. But this is really cumbersome. I didn't really want to do this. It turns out there was an out. People found that there was this value2 property that does almost the same thing as value. And so it doesn't actually have the optional parameters. And so people would just say value2 equals. But I want to actually get rid of all of this. I want to treat this really nicely the way that I would in VBA. And so again, with the power of dynamic, I can actually get rid of this cast completely. And this is because we're treating, we're treating here that when something is returned as object from COM, we're going to treat that as if it was treated as dynamic. It was returned as dynamic. And this is because that's how VBA and VB.NET actually treat these things. And so the object model is designed assuming that when something actually returns object, you can then dot off of it arbitrarily. And so if we want to provide that same experience, that VBA experience in C#, we have to actually provide that functionality when we're targeting something, like specifically COM, that actually, so it can actually behave the way that the object model would expect. So we can play the object model's game and speak its language. And so the benefit, though, one extra benefit I get is now that I'm actually doing that, and this is now a dynamic call, because the indexer that I just called there returns dynamic, so the dot after it is a dynamic call. It turns out that the COM runtime binder, that the dynamic language runtime, the system we have for handling all of this, actually provides, does understand indexed properties. We actually do have that ability, and so I can take off the 2. And so I can actually then cleanly represent all of these, just as if I was in a language that actually supported indexed properties. So I can now type this, and this is very close. Turning brackets into parentheses would be very close, actually identical to what I would be writing in VBA. And so I'll go and I'll do it down here too, because I have the same situation here inside my for each loop. Again, getting rid of the cast and changing value2 to value, because now it's acting dynamically. And I now have my code. I've transformed it. And when I run it, it should do exactly the same thing as it did before. Yep. And so I now have a spreadsheet. It appears I have an ID in a balance column, and I have my values in there. OK, so now let's get it into Word. Let's finish the application we're making. So I'm going to copy this stuff to the clipboard. And I'm going to call this function. And you notice that I'm actually calling another one of these get underscore methods. Let me restart this here. Some of our IDE support is still in progress, so you have to bear with me a little bit. Let's let this come up again. Shouldn't have lost too much of our work since we just ran it. OK. Maybe it won't highlight get range this time. OK, and so I'll come down here. And we'll add this get range call. And you notice that it is still this get underscore range call. And it's not, I haven't actually cleaned it up. And this is actually one of the features that we are still taking under consideration if we want to handle indexed properties. And if we want to bring them into the language as some sort of actual functionality. We've sort of added a lot of this other COM benefit, but this is one of those places where actually having the capabilities that match the target language that you're talking to in this case, or the target language of the object model you're talking to expects, in this case VBA, if we had those features in C#, we would be able to have that more rich experience, the experience that more closely matches the original experience I had coding in VBA directly. So I'm going to leave this alone for now. And then I'm going to go on and I'm going to say paste to Word. And so I'm bringing this code now into Word. And again, some of the stuff looks fine. I'm saying var word equals new word at application. That's great. I'm setting word visible equal to true. That's fine. But now, again, I have these kind of these methods that are taking these missing parameters. And because this is Word and the Word object model sort of fights you along this way, it's even harder. Because as Word defines its methods, it often has ref parameters. They've declared a lot of their parameters by ref. And it turned out this wasn't an issue in VBA because you could pass values to by ref parameters. And you could pass literals, you could pass the results of expressions, and it would just ignore the fact that it was ref in that case. But C# is very explicit. When you're calling a ref parameter, you have to explicitly pass it something, some variable that you could actually get a value back into. And so, again, because we're talking to this kind of API that has a certain assumption, the assumption you can just easily pass values to ref parameters, we have to take that same assumption on when we're actually talking to COM. And so in this case, I'm saying here, ref missing, but I'd really like to just be able to leave this off the same way I could for the previous optional parameter cases. And it turns out we can. So when you're actually talking to a COM method, a method on a COM type, we have a feature called omit ref, which lets you leave off the refs. So if I know that I'm just passing a value and I don't actually care about it coming back out, C# will relax its rule about me actually sending a variable because it knows it's dealing with a language, with an object model that has that loose restriction there, where I can actually send that kind of stuff. And I'm able to actually go ahead and do the same thing down here, too. I'm saying word.selection.paste special. I have a bunch of ref parameters. I can get rid of all of the parameters I don't care about. And then for this one parameter I do care about, if I actually hit parens, I can see that the second parameter here, link, is the parameter I want to actually send a value to. And I can just say now link : true. And then delete the rest of these parameters. And now I don't need my temporary variable that I was using to have a valid ref call. And I can get rid of my missing because I was able to just leave all the missing parameters out. And now my code is very clean. And I'm back again to the kind of experience I would have in VBA. It's still slightly flavored like C#. It's C# syntax, but it feels very much like I'm actually fluent in the object model that I'm actually talking to here. So we'll go back to the slides and take a look. And you can see, basically, yeah, we've now achieved this goal that we actually had with VBA and VBA.NET. The code that I wrote for C# 4.0, except for the fact that we used colon instead of colon equals and have a semicolon, is really the same as the VB.NET code I'm able to write. It's now much shorter, and I don't have that whole baggage of missing parameters and having to worry about refs. And so the last thing I'm going to show is actually just a short demo of us talking to IronPython and being able to use these IronPython libraries as if they were real libraries that were defined statically in the .NET world, and that I was able to just import them as easily as I was doing using in C# or I would do in imports in VB. And so I'll go back to the demo. I'll go down to Python. And over here, I've actually brought in this hello world.py file. And it's just a really simple Python file. All it does is declare one function. Function welcome takes a name and then returns you back a string that says hello that name from IronPython. OK, so I'm going to use this now, and I'm going to try it out. So I'll put in some code here. And you'll notice, if you remember that whole big chunk of code I showed you before, this is actually much easier for me to write. I'm not going to actually put the whole thing in because the DLR has actually changed so much that it doesn't even work anymore. It turns out there actually is no way to pull that off. But what I'm going to use here is the new support we've made, sort of the real way that we've given you to do this now. And it's pretty simple. All I have to say is script runtime, make a variable that represents my Python environment, so python.create runtime. And then I say, here, dynamic hello world. equals py.usefile hello world.py. And I now have this hello world variable that represents the module, as if I had typed import hello world in Python. And if I come down afterwards and do hello world out, I'm just going to loop through 1,000 times. I'm going to make up some names, some strings, employee number 0 through 999. And I'm going to output this. I'm going to call the welcome function here. I'm going to call hello world.welcome, have it translate this to a string, and I'm going to output the resulting string. And so I'm going to hit Control F5. I'm going to run this. We'll see we're loading the hello world Python file. It gets loaded into memory, and then as soon as it's able to go, I am able to call that function 1,000 times. And the DOR is actually doing its job to cache that method invocation. So after it figures out what that should mean dynamically, the next 999 times I call it, it's much faster because it's it's resolved down to a delegate that actually represents how to do that specific operation with just a simple test to say, is this the same thing we've done before? And so that's that. I was actually able to call into some Python library almost as easily as if I had just said using hello world, and it was some namespace for something I defined in C#. And so I'm actually going to just go back. That was just a simple quick demo to just give you a feel for how that works. I'm going to go back to the slides and just show that basically in sort of an equivalent situation here, if I had some random module where I was calling random.shuffle, in Python I would say import random, and I would call random.shuffle on some items array that I have. But now in C# 4.0, the equivalent thing to do is equally short. All I have to say is dynamic random equals python.usefile random.py. It's a little bit more verbose, but there should be some difference to the fact that I'm now actually calling into something from Python. But it's not that much for me to actually type. And once I get back that random object that represents the random module, I can use it just like I would use it in Python. I can start calling .shuffle and pass it objects, pass it some items array that I have, and have it process that in place and actually affect my .NET objects in the Python code itself. And if we went to look at what VB10 would look like, it would look exactly like the same thing. I'm able to say, again, dim random as object, because that's the mechanism by which we're doing this whole iDynamic object kind of binding. But I'm able to do this now exactly the same way. I have really short code, and I can do it from either C# or VB. And I now have access to a whole wider range of libraries that I can consume. Not just those that are actually statically typed and live very close to the way that I'm programming right now. And so, yeah, to sort of pull that all together, C# in 4.0 and VB10 are adding these features, features such as the dynamic support, and features such as named and optional parameters and omit ref, because these features are expected by the object models we want to have quality consumption of. If we want to talk to these COM object models, we need the named and optional parameter support in C#, the support that VB's had that's given them the real benefit when actually doing that kind of interop. And they talked to the HTML DOM, the sample I did with Silverlight, but also the Python sample. We want to do dynamic dispatch, because we're actually talking to something that's dynamic. And we had some hack to get around it with the HTML DOM, where I could call .invoke and .create instance. But that hack wasn't really, just because it was statically typed, it wasn't really any safer. Because the real thing, the thing that I could mess up, the name of the method or the name of the type, was being passed as a string anyway. And so I wasn't getting any static typing benefit by calling into that other way of doing things. And so this dynamic support that I have gives me that much terser syntax. And in the case of Python, actually enables something that I couldn't do before. And so that's the demo. So just a quick thing for the lunch session here. If you guys want to actually try this out, you can go to the top link. Again, this stuff is only enabled right now for C#, even though, as with the code samples you saw, we are planning to add this equivalently to VB using their existing late binder. But if you want to try this now, you can download our C# samples package, the C# dynamic samples package from that address, MSDN Code Gallery /C# Future. And you can try out the Silverlight starter project. And that's the thing I started with when I did the Silverlight demo that actually let me use Silverlight on the VS 2010 CTP, which normally wouldn't actually work. We've found a way to actually make that work, so you can try this kind of stuff out. You can try out dynamic with it. You can also download the VB Future demos and the samples. And we have a special release of Iron Python that's designed for this CTP. So if you want to play with Iron Python interop, then you should go get that. And if you're interested in this kind of stuff, if you're still interested, the one thing I do recommend is actually the one on the bottom. If the deep dive into dynamic languages in .NET, Jim Huginen's already given this talk, but all the talks are actually going to be available online. So as soon as that's available, if you're interested in exactly how this whole dynamic language runtime thing works and more details about a dynamic object, I'd highly recommend that. Also today, at 5:15, you're going to go in. Paul Vick is going to go more into specific detail about Visual Basic. And just some other events too. Anders Hausberg, if you didn't get a chance to see it, is repeating his original talk, The Future of C#, that he gave yesterday, along with a panel, sort of with everyone who's anyone in programming languages. So that's it. Thanks for coming, guys. Fill out your session evals at microsoftpdc.com. And again, you can get this stuff as recordings. And I recommend the DOR talk that Jim Huginen did. So thanks.